Hey guys. All right, on this video, we're going to talk about kind of compound probabilities. So you found like probabilities of simple events, like what's the probability if I pick a card, it's a king? Or what's the probability if I pick a flower, it's red? All right, where it's just one thing, like a simple sentence. Just like in English, you can have compound sentences with ands and ors. So you can have the same thing with probabilities. You can have compound probabilities. So we're going to talk about ands and ors. So I'm going to pull up this PowerPoint, hopefully, and we'll see how it goes. Okay, so or and probabilities, so compound probabilities. All right, be a problem like this. What if I said this? What if I took the numbers from 1 to 10 and I wrote them on separate pieces of paper? So I put the number 1 on a piece of paper and I folded it up. I put the number 2 on a piece of paper and I folded it up. So I've got 10 pieces of paper with one number on each, folded up, and I stuck it in a bag. All right, and so I'm going to shake them up. So you're going to reach in and pull one thing out. And you win if you have an even number or if you have a number bigger than 6. So I want you to stop and think about what you think your probability of winning would be. So you win if you get an even number or if you get a number bigger than 6. Okay? Now, your first instinct may be right, but we have to fix it a little bit. So here's what I mean. I'm going to kind of do this one a longer way. So does everybody understand that on separate pieces of paper, I've got a 1, and then I've got a 2, and a 3, and a 4, and I've got a 5, and a 6, and I've got a 7, and I've got an 8, and then I've got a 9, and I've got a 10. All right, so there are 10 different pieces of paper. Now, what would be winners for me? All right, do you understand that there are 10 things? All right, so which one of these are winners? Would 1 be a winner? Because it's not even and it's not bigger than 6. Do you understand that 2 would be a winner because it's even? Well, 3 is not a winner, but 4 is because it's even. 5's not a winner. Now 6 is a winner. 6 isn't bigger than 6, but it's still an even number. And if it's even, I win, or if it's bigger than 6, I win. So do you understand that 7's going to win me something because it's bigger than 6? 8 would be a winner. I mean, it's even and bigger than 6, 9's still a winner because it's bigger than 6, and 10 would be a winner. So these are all the pieces of paper that I could pull out that would either be even or bigger than 6. So that's 1, 2, 3, 4, 5, 6, 7. So my answer would be 7 out of 10. Now, some people kind of want to do this. They want to kind of do the even ones. I'm just going to put E for even. And then they want to separately do the numbers that are bigger than 6. And then they want to add them. And that's a good idea, but look at why that's not exactly going to work. Okay, if you do the even numbers, you're going to count 2, 4, 6, 8, and 10. So 2, 4, 6, 8, and 10. So that'd be 5 different numbers. All right, out of your 10. Okay. So you counted the 2, you counted the 4, you counted the 6, you counted the 8, and then you counted that 10. Okay, so that's where I got the 5. 1, 2, 3, 4, 5. And then plus, now, out of the 10 numbers, which ones are bigger than 6? All right, do you see that was 6 isn't bigger than 6, but 7 would be, and 8 would be, and 9 would be, and 10 would be. So I would get a 4. But the right answer is not 9 out of 10, it's 7 out of 10. All right, do you see why? Do you see that I double counted this 10 and I double counted that 8? So I'd have to take off the double counts. Okay, so if I'm going to do it this way, I'm going to have to subtract all the ones that were both, because that's the ones I double counted. If they were even and if they were bigger than 6. Okay, so that's really bigger than 6. So I'd have to take off, you know, 2 of them. So when I did that, I'd get the right answer 7 out of 10. In other words, I need to take off these 2 check marks because I've already counted them when I counted the X's. Okay, so that's the reason that this next page is going to give you the formula for OR. All right, so here's going to be your formula for OR that you need to write down. It's on your formula sheet. All right, but you need to learn it. The probability of A or B is the probability of just A by itself, plus the probability of just B, and then minus the probability that A and B can occur at the same time. So that means they're happening at the same time. So what this is doing is it's subtracting your overlap. It's subtracting all the ones you double counted. All right, so let me kind of show you what I'm talking about. If you pick one card randomly, so we've got a deck and we shuffled it up, and you're gonna, you know, close your eyes and pick one card, and I want to know what's the chance it's a red card or a king. Now remember, we talked about this, but if you want any kind of partial credit, I need a P and what you're looking for in the parentheses. So red or king. All right, so does everybody understand that this red is my A and that king is my B? All right, and my formula up here, remember, said the probability of just A, so the probability of just the first one, red, plus the probability of just B by itself, so the probability that it's the king, minus the probability that you can have both at the same time. So it's real important that you understand that this and in this formula means at the same time. Okay, so that's why, let me kind of pull this up here. On your formula sheet, probability of A plus the probability of B minus the probability of A and B. So that A and B means they happen at the same time. So it's kind of like 3 separate problems that you put together. All right. When you pick one card, what's the chance it's red? Now remember, what's in parentheses goes on top and the total goes on the bottom. So there are 52 cards in the deck. Of those, how many are red? Half of them, 26. All right. Plus, like starting over. All right. Total's the bottom, 52. Of those, how many are kings? Remember, there's a king of hearts, a king of clubs, a king of spades, and a king of diamonds. So there's 4 kings. Minus. Now, of the 52 cards, are any red and king both at the same time? Well, see, the red of hearts is a red and a king, and the red of diamonds is a red and a king. So that's the 2 cards that are red and king. You know, you have to have a common denominator when you're adding and subtracting fractions. So don't try to simplify them here. You're going to undo what you need. So I need a common denominator, and then I just 26 plus 4 is 30 minus 2 is 28. Now you can't leave it like that. It's not reduced. You can either reduce it to 7/13, or if you don't really like fractions, you can get an approximate decimal. So if you're going to remember what we said, if you're going to change to decimals, you need to round to 3 or 4 decimal places. So if you took your calculator and did 28 divided by 52, you would get about a decimal 538. Okay. So if you'd rather have decimals, then you are certainly welcome to do that. And the back of the book tends to use decimals a lot. But make sure you round them off, don't chop them off. Okay. Look at this one. If you pick one card randomly for the deck, so the same thing, we start over, we shuffle the cards up, you close your eyes, you pick one card. I want to know what's the probability that it's a black or a heart. So if you want partial credit, you got to put in parentheses what you're looking for. So the probability of black or a heart. So it's a probability of just the first one plus the probability of just the second one minus the probability that's black and heart both at the same time. Okay, well, think about it. Out of the 52 cards, how many are black? Half of them. All right, here's your hearts. Out of the 52 cards, how many are hearts? There are 13 hearts. Now think about it. How many cards in the deck are black and heart both at the same time? Do you understand that's impossible because the hearts are red? So remember, when something cannot happen, what's its probability? 0. So you don't end up subtracting anything. If you'd rather put 0 over 52, then you can do that, but you don't have to. Remember, when something is not possible, the probability is 0. So I get 39 out of 52, so I get 3/4. Again, if you prefer a decimal, that's exactly 0.75. So that's the reason you don't have to go to 3 places, is because it terminates. Okay. So with or, make sure you're clear, all right, that you've got your formula on your formula sheet. So it's the probability of A plus the probability of B minus the probability they happen at the same time. Now, again, just like usual, I'm assuming you're pausing the videos and taking notes with all these formulas and examples, but you don't have to memorize that because it is on your formula sheet. All right, come look at this one. All right, your author really likes a table, but I need you to write this definition in your notes. Mutually exclusive events are events that cannot happen simultaneously. So they cannot happen at the same time. Okay, so back on this video, on this slide here, do you understand that hearts and black cards are mutually exclusive? If you know it's a heart, it can't be black. If you know it's black, it cannot be a heart. Okay, they cannot happen at the same time, so they're mutually exclusive. So when you have mutually exclusive events, this and part is always going to be a 0. So the book kind of acts like they're 2 different formulas, but we're just going to use this formula all the time, whether the events are mutually exclusive or not. It's just if they're mutually exclusive, this part right here is going to be a 0, but subtracting 0 is not going to hurt anything. Okay. Now look at this one. The author likes the table. It says if you randomly pick one flower, so you just close your eyes again and reach in and pick a flower, what's the probability that it's red? Well, remember what you do. On the bottom goes your total. So you'd have to count these up and realize that's 17 in all. And then you got to have your red cards. Now, the lovely thing about a table is you can circle things. So do you understand that this whole first row are your red cards? So that's 7 in all. And that won't reduce, so that'd be my final answer. So the lovely thing, make sure you do it in pencil so you can erase it. All right, look at the next one. Instead of doing the probability that it's red, what if I said you pick one card, what's the probability that it's a tulip? This is like the very first video. The total goes on the bottom, and I need all the tulips to go on top. Now, again, do you see that this column are my tulips? So that's 4, 6, 3 is 9. So there'd be 9 tulips. So 9 over 17. And again, that won't reduce. Okay, but you can use decimals if you want to. Now here's an or one. So remember, it's the probability of just the first one, red, plus the probability of just the second one, tulip, minus the probability that should be and, that it's red and a tulip. Okay. Now, the lovely thing about a table is you can circle and see where the overlap is. So remember, here were my red ones. All right, so there's the probability that it was red. So that's where we got 7 out of 17 plus. All right, what's the chance it's a tulip? So that's like starting over. Your tulips are all of these cards. All right, all these flowers here. Okay, so again, that's my 9 out of 17 minus. Now, were there any of these that are red and tulip at the same time? Do you see that we counted this 4 when we counted the red ones, and we counted this 4 when we counted the tulips? So there are 4 that are red and tulip. So I had to take them off. But the lovely thing about a table is if you circle, you can actually see what numbers are double counted, and you know what to take off. So keep that common denominator of 17, and then 16 minus 4 is 12. So there's that answer. Okay, well, let's do another one. All right, probability of yellow or a rose. All right, remember what goes on the bottom is my total. So there's 17 in all. All right, so let's go look at our yellow ones. All right, our yellow ones are going to be this bottom row down here. All right, so there's 7 out of 17 that are yellow. All right, plus, all right, it's like starting over. Now I win if I get a rose. So out of my 17 now, I need to know how many are roses. So remember, my roses are going to be this first column here. All right, well, that's 4 and 4 is 8. So I have 8 out of 17. All right, minus. All right, what's the chance that they're yellow and rose at the same time? So out of the 17, how many are double counted? Do you see again that 4 got double counted? Now it's not always going to be the number 4. It happens to be a 4 this time. because I counted those 4 cards. Those 4 flowers are roses and yellows. So I'd have 15 minus 4. All right, so that's going to give me 11 out of 17. And again, that's not going to reduce. So that would be my final answer. Now, sometimes you might not have any overlap. If you don't have any overlap, then you would put a 0 there. Okay? Because if I said, what's the chance that it's red or white? Well, these would be your red ones. You know, that'd be 7 out of 17. These would be your white ones. That'd be 3 out of 17. And then it'd be minus 0 because these don't overlap. All right, so remember, those would be mutually exclusive. So if there's no overlap, there'd be a 0 right there. Okay? All right, so that's how you do or probabilities. So make sure you start learning that formula to be comfortable with it. Now, let's talk about and probabilities. Now, this and in this formula is different than the and in this formula. This and means at the same time. That's not what this and means. All right, look what it says. When it asks you, what's the probability of A and B? What it's meaning in your book is that event A occurs first and event B occurs second. So you're only going to be able to do this if you're doing more than one thing. Now, the book puts the probability of B, that bar means given that A has already happened. See, A occurs first and then B occurs second. So when you're doing this second probability, you have to assume that this first one has already happened. All right, you'll see what I mean in just a second. Now, here's the catch. Before you grab this and formula, I need you to ask yourself, is this possible? Because if the answer to that is no, you do not use that formula. If the answer is no, the probability is 0, because when something is not possible, its probability is 0. Now, I'm going to let you do something that may not be a good idea, but we'll see. I'll let you just put the probability of A times the probability of B if, big if, all right, we're going to multiply these, if you can remember that when you write the probability of B, you really mean this. This second probability assumes that this first one has already happened, okay? And I think you'll see what I mean in just a second when we work some examples, all right? So let's go look at some. All right, look at this one. Again, we're going to pick 2 cards from the deck. So I'm going to pick 1 card and then I'm going to pick a second card. So I'm not picking them at the same time. I'm picking the first card and then I'm picking the second card. And I want to know, what's the probability that you get a heart and a black card? So do you understand? I mean, you're going to get a heart when you pick the first card and then you're going to get a black when you pick the second card. Now, there's something I haven't told you up here in this problem that you need to know. Because if you don't know it, you're not quite sure what to do. And that is, are you putting the card back or not? Like when you pick the first card, are you putting it back before you pick the second card? Because that's going to change the answer. I'm going to show you why. So the way I'm going to phrase that on a test is I'm going to say with replacement or I'm going to say without replacement. So with replacement means when you pick the first thing and record what you got, you put it back before you pick the second time. Without replacement, it's going to mean once you pick it, it's gone. All right, so look at the difference. Probability of a heart and a black card. So before I grab that and formula, I ask myself, is it possible? If I'm picking 2 cards, can I get a heart the first time and a black the second time? Yes, that's possible. So if that's possible, then I do my formula, which is the probability of the first one times the probability of the second one. But remember, when you're doing this one, you assume this has already happened. All right, but it's like, again, separate problems. So what's the chance when you pick the first card, it's a heart? Well, aren't there 52 cards in the deck and aren't 13 of them hearts? So I've got to assume that I've drawn a card and it's a heart. So what am I doing with this heart? Because it says with replacement, I'm sticking it back in the deck. All right. So when I go back in the deck, how many cards are there? There are 52 cards. Of those, how many are black? Half of them, 26. Now, you don't have to have a common denominator to multiply, but you can. If you wanted to reduce these, you could, but since I've got a calculator, it's kind of a waste. I just do 13 times 26 and get 338, and 52 times 52 is this number. And I didn't really want to reduce that nasty fraction, so I just went to a rounded off, this wasn't a decimal. It came out to be exactly 0.125. Okay, so if you think in percents, that's about a 12.5% chance. Not great. Okay, well, look at the difference. You pick 2 cards from the deck. What's the chance you get a heart and a black card? But this time I'm saying without replacement. So once you pick, it's gone. So is it possible to get a heart the first time and a black the second time? Yes, that's possible. So if it's possible, I grab my formula. The probability of the first one times the probability of the second one. All right. So what's the chance the first card's a heart? Well, again, your total goes on the bottom and your hearts go on top. But now look what you have to do. You got to assume that in your hand is a heart. This time, what are you doing with this one heart? You're not putting it back, so it's gone. So when you go back in the deck, what's the chance it's black? Well, now your total is not 52. Your total is only 51. Remember, you kept a card. Okay, of those 51 cards, how many are black? 26, because the one you kept was a heart and that's red. Okay, so see, you've got, when you're doing this, you've got, when you do the second one, you assume this first one has already happened. So then I do 13 times 26, so I still get 338, but now I've got 52 times 51. So I get a different number on the bottom. So my probability comes out to be a little bit better if I don't put that heart back. Because remember, I'm trying to get a black card. So that's one less red card to trip me up. Okay, so it matters whether you're putting cards back or whether you're not putting cards back. Okay, now look at this one. If you randomly pick one card from a deck, what's the probability that you get a heart and a black card? Now, so I write down, what's the probability that I got a heart and a black card? Now, remember what I said back on this slide over here. Before you grab that and formula, you've got to ask yourself, is this possible? Are you going to get tripped up? Now, look at this. I'm getting one card. If you're only picking one card, can it be a heart and a black card? Is that possible? No. So this answer is just 0 and I'm finished. There's no work. If something is impossible, the probability is 0. You don't go grab this and form, this multiplying formula if it's not possible. So before you grab that and formula, you ask yourself, is it possible? And if the answer is no, then the answer is 0. Don't write down not possible. Probability is a number, not a phrase. It's a number between 0 and 1 inclusive. Okay. All right, let's go look at another to make sure we're still okay. Now, there are 2 other vocabulary words you need to learn, independent and dependent. All right, when things, if I tell you that I'm real independent, does what you do really affect me very much? Well, that's what it means here. When 2 events are independent, the occurrence of one does not affect the probability of the other one in any way. So the fact that one happened doesn't mean the other is more or less likely to happen. One doesn't affect the other at all. 2 events are dependent if the occurrence of one does affect the probability of the occurrence of the other. So dependent, one affects the other, independent, they don't. So look down here, independent or dependent. What if you flip a coin 2 times? Does your first flip influence in any way what you might get on your second flip? Do you understand? No. So this would be independent. Just because you get ahead on the first flip doesn't mean that you can't or must get ahead on the second. It doesn't have anything to do with the second flip. Okay. What if you flip a coin and then you roll a die? Does the flip of the coin have any influence on what you might or might not get when you roll the die? No. See, these again are independent. Okay. What if you pick two cards with replacement? So I pick a card, I've got the Queen of Hearts. I put the Queen of Hearts back and I do them again. I pick again. Does the fact I got the Queen of Hearts, the first pick, influence in any way what I might or might not get the second pick? No. So again, this is independent. But look at this one. What if I pick two cards without replacement? So I pick the first card and it's the Queen of Hearts and I throw it away. So when I go back in the deck, did I affect at all what I might or might not get? Yeah, I'm sure not going to get the Queen of Hearts because it's gone. I'm less likely to get a red card because I threw one of those away. I'm less likely to get a queen because I threw one of those away. Okay, so when you don't put things back, things become dependent. It starts changing top numbers and bottom numbers. So make sure that you're clear about independent versus dependent. Now, I don't want you to confuse independent and mutually exclusive. All right, I want you to think about this and then think about my answer. Are mutually exclusive events independent or dependent? All right, this is where people get confused. Mutually exclusive events are not independent. They're like ultimately dependent. All right. In other words, they're so dependent when one happens, the other can't happen. It just knocks it all out of the possibility. So I don't want you to confuse mutually exclusive with independent or dependent. Mutually exclusive means they cannot happen at the same time. Okay. Independent means one doesn't give you any information about the other one, doesn't affect it at all. All right. All right, let's go look at another example to make sure that we're still okay on the and stuff. All right, because like I said, sometimes your author likes a table. If you pick two flowers without replacement, what's the probability that you get two red flowers? Now, sometimes they'll phrase it like this. Sometimes they'll say, what's the probability that they're both red? Well, now I don't see a connector word. This one said, what's the probability that two are red? Okay, so sometimes they'll say something like both red, sometimes they'll say two red. Well, that's more than one thing. Both is two things, so there's got to be a connector word. So sometimes you have to reason out the connector word. What's the only way they'd both be red? Wouldn't your first one have to be red and your second one have to be red? So the only way to get two red flowers if the first one was red and the second one was red. But they're not going to say, what's the chance you get red and red? You have to figure that out yourself. Okay. Now, again, I've got to ask myself, is that possible? All right. If they let me pick two flowers, can I get two red flowers? Well, since there are 7 red flowers, the answer would be yes. Okay. All right. Let me go up here so you can see the problem a little bit better. So remember, I've got roses and tulips. I got red one, white one, and yellow one. So if they let me pick 2 flowers, could I get 2 of them to be red? The answer is yes. So I grab my formula. So the probability of the first one times the probability of the second one. Well, now I've got to know, am I putting them back or not? So remember, without replacement means I'm not putting them back. So when I go in to get the first flower, what's the chance it's red? Well, remember when we added before, we had 17. Of these 17 flowers, how many are red? 7. So in my hand, I assume I've got 1 red flower. Now, what am I doing with that 1 red flower without replacement? It's gone. So when I go back in for my second pick, how many flowers are there? Well, now there's only 16 flowers. And of those 16, how many are red? Only 6. Remember, the flower that I threw away was red. So you've got to assume that this first thing has happened. Well, 7 times 6 is 42. 17 times 16 is 272. So I divided those and rounded to 3 decimal places. All right, look at this one. If you pick 2 flowers, this time with replacement, what's the probability you get a red one and then you get a yellow one? So a red on your first pick and a yellow on your second pick. Is that possible? If you pick 2 flowers, can you get a red one and then a yellow one? Yes. All right, so then I grab my formula, the probability of the first one and the probability of the second one. But remember, what we're saying is it's really the probability of yellow given that you got red the first time. Okay, so the first time I go in, there are 17 flowers. Of those, all of these top ones up here are red. So there's 7 red. Now, what am I doing with this one red flower? With replacement, I'm sticking it back in. So it's back in now. So when I go to pick, you understand there's still 17 flowers now because I put it back. Of those, how many are yellow? Well, it just so happens there are also 7 yellow ones. So that's why I got 49 over 289 and rounded off. Okay. So hopefully, remember with and with or, with and you multiply, with or you add and subtract the overlap. All right. So if you need some help, make sure you contact me. All right. And let me know and I'll be happy to help.